Okay, in this video I'm going to show you how to evaluate the double integral over R of 4 minus 2y dA. Where R is the region, it's a square region in the xy plane defined by the interval from 0 to 1 on the x-axis and the interval from 0 to 1 on the y-axis. So it's this square region right here. And okay, the integrand is f of xy equals 4 minus 2y or z equals 4 minus 2y, and that's a plane that I've drawn here. I've shaded it in black here. It's a plane with z-intercept 0, 0, 4 right here and y-intercept 0, 2, 0 right here, and it runs parallel with the x-axis since the x variable is missing from the equation. Okay, now above the region R, the square region R in the xy plane, the plane z equals 4 minus 2y is positive, so that the double integral just represents the volume between the plane and the region R in the xy plane. To see what that figure would look like, I can erase just part of this and draw just the part above the region R in the xy plane, and you can see that basically you have a box shape, and on top of that you have a wedge shape, and that figure, the volume of that figure will represent the value of your double integral. So okay, let's start by finding the volume of this box right here. The volume of the box, well, it's just a 1 by 1 by, it's got to have a height of 2, because if you plug y equals 1 into this equation over here, you'll get z equals 2. So it's just a 1 by 1 by 2 box. So it must have a volume of 2 cubic units. And then this wedge shape up here is actually going to have exactly half the volume of the box we just found, because its base is still 1 by 1, and its height must also be 2, since this is 2 and the total height is 4. This must also be 2, so that this wedge shape will have exactly half the volume of the box we just found. So that's 1 by 1 by 2 times 1/2, or just 1, which means the double integral is just the sum of those two volumes, which is 3 cubic units.